We are beginning lesson 6.2. This is about identifying linear and quadratic equations. And we're going to start off with the linear equation. This is on page 192. And I want to look at an example of how a linear equation is derived. Okay, so this is linear equation. Linear means in a line. So I'm going to walk you through, this is a pretty complicated process. So I want you to be patient with yourself. We'll go through this slowly and you'll see some patterns emerging here. So to start with, I want to draw a table of values like the one on 192. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8 rows. So draw this with me. I think that's right. Nope, one more. 8 rows. And this needs to be very, very, very wide. Okay, because we're going to do more than just plot some X's and Y's here. We're looking at some theory, and that's always a little bit more than just the basic stuff. So in the first column, we're going to put some values for X. Let's go ahead and do this. So we're going to put some values in here for X, and I'm going to go ahead and give those to you. We want -3, -2, -1, 0, 1, 2, and 3. So these are going to be my X values. And then we're going to draw another column about like so. And I'm going to give you a function for this column. This is the Y column. But instead of giving you the easy Y's, we're going to have to work for these Y's. So 2x minus 3, that's the function that will give us the Y value. So I'll plug in an X value and I'll get an output there. And then in that last column, we're going to do something in just a minute. For now, let's just leave the last column alone. So for this first value of X, here's X and here's X. So everywhere I see an X, I'm going to be substituting. So here we go. F of -3 is going to be 2 times -3 minus 3. So that would, you can do that in your calculator if you need to, but it would be -6 minus 3, and then we're going to put in the equals. So -9 is the value when X is -3. Okay, let's plug in F of -2. And we get 2 times -2 minus 3. So we get -4 minus 3 is -7. Okay. Then F of -1 is 2 times -1 minus 3. So -2 minus 3 is -5. Then F of 0, this is the y-intercept, 2 times nothing minus 3. So that's going to be 0 minus 3, which is -3. And you may already be seeing a pattern here. That's what I want you to notice. Do you see a pattern emerging? Okay, so F of 1 will be 2 times +1 minus 3. That's 2 minus 3, so that is negative 1. And then f of positive 2 is going to be 2 times 2 minus 3. So 4 minus 3 is positive 1. And then finally, f of 3 is 2 times 3 minus 3 is going to be 6 minus 3, or positive 3. So we basically have come up with some points. Here are our x values. And remember, the function test says that you cannot have any duplicated x values, and we do not. So we do have a function here. And here are the y values that correspond to those x's. And I'll tell you what, do I want a graph or do I not? Let's hold off on the graph. We've got enough here to worry about. Now, there's one condition to this working out. The x's must be consecutive, which means that you start at 1 and you don't skip any. So for example, if I had skipped negative 2, this would not work. It has to go in consecutive order, which means 1 by 1 by 1. That is true of your x values. So here are the x's. And I gave you the y's. Let me just highlight those all in blue because this was the output. Nothing's changed. We're still graphing x's and y's. We're still doing domain and range. We're still doing all of that. It's just that instead of working these down on the page, I've worked them in the row that they're on. Okay, so you still have domain, and you still have range. Nothing's changed. You still have points that you can plot, that we will plot in just a minute. So this last column, I want you to put something in here called the consecutive difference. Now, you don't really have to remember this. I just want you to see a pattern that emerges here. So this is called the consecutive difference column. And I'm going to highlight this one also, just because that helps the eye to understand. I'm a firm believer that color also triggers parts of the brain that help you remember. It just helps you compartmentalize information. So color is your friend. All right, so what does this consecutive difference business mean? Well, I know that the word difference means subtraction. So the type of math that's coming up will be subtraction. So here's what we're going to subtract. Well, what happened? There we go. I don't know what happened. I hit something. So we're going to take two numbers in order. I'm going to take the negative 9 and the negative 7. They have to be side by side. I can't do negative 9 and negative 1 because they're not side by side. They must be consecutive. So I'm going to say negative 9 minus negative 7. Okay. Or negative 7 minus negative 9. It doesn't matter. But difference in this case is that subtraction sign. So what is negative 9 Wait a minute. It does matter. Excuse me. My goodness. It's been a very long time since I've looked at this. Forgive me. It does matter. This value comes up here. So you take the negative 7 minus the negative 9. I'm sorry, it does matter. And now I remember this. The arrows made me remember. So negative 7 minus negative 9, do that on your calculator if you need to. That is 2. Okay, let's bring this negative 5 up. And the one right above it is negative 7. Negative 5 minus negative 7 is 2. So let's bring the negative 3 up. Maybe it was just a coincidence. Negative 3 minus negative 5 is 2. Bring the negative 1 up. Negative 1 minus negative 3 is 2. Okay, now we're getting into positive numbers. So will that same process hold? So let's bring the 1 up here. Minus negative 1 is 2. And then let's bring this one up here. So 3 minus 1 is 2. And I don't have anything to bring up here, so we just leave that last row blank. There's nothing you can put in there. So look at this. It doesn't matter what the x and y's are, that pattern holds true. So what we would say is that the consecutive differences, or it's really just one difference, the consecutive difference is 2. Not the consecutive is 2. The consecutive difference is 2. We can also say that the consecutive difference is common, meaning it's the same all the way through the table. And if we kept finding more and more points, it would be common. As long as the points are on the line of this equation, it would be common throughout the table. Okay. And I think I'm going to leave it right there. I think we're not going to graph this particular function. Let me think if there's anything else I need to tell you here. Let me look back at the book. I believe I've told you everything about a linear function. This will be true for any linear function.